Hi, my name is John Kim. Welcome to the study room, SAT tutoring. Not SAT, excuse me, AP Calculus. This is the book I'm using. This is part 2. Notice this is the 11th edition right over here, and we're going to be using this book. It's the best one out there for studying, so I definitely want you to study with this if you're going to be studying for the AP exams. Anyways, let's get started with some questions. This is the second part of Barrons 11th edition differentiation. Okay, so let's get started. We're going to be doing the examples from differentiation. F of x is sine of x over x squared, tangent of 2x squared plus 1, cosine cubed of 1 minus 3 theta, e to the sine of x plus 1, 1 plus sine squared of 3x to the 4th power, and y equals sine of ax plus b. If you're having a little bit of problem with this, just let me know. I'm trying to get the lights a little bit to look a little bit better. Maybe I should turn it off. Maybe better. Anyways, let's get started with some of the problems, okay? So the first example is 8. I wrote it out for you. Example number 10. Oh shoot, where's example number 8? 10, 8, there it is right there. Misplaced it. So I thought I had it all in a row. Let's get started. Okay. So the function f of x is equal to sine of x over x squared. Let's try to take the derivative. What I'm looking for is f prime of x. Since it's some function divided by another function, sine of x over x squared, let's label this f. Let's label this g. The derivative of a quotient function is f prime times g minus g prime times f all over g squared. I like to memorize it this way because f prime times g minus, instead of a minus, you just put a plus there for the product rule and you get rid of the g squared. So f prime times g plus g prime times f, that's the product rule. Put a minus over g squared, that's the quotient rule. You could use your old-fashioned method. There's lots of different ways to rewrite this, okay? Anyways, so before I start, I also like to find the derivative. F prime, the derivative of sine of x, is going to be, cosine of x. The derivative of g of x, which is g prime, which is going to be 2x. Take the power, bring it on down, subtract 1, and so it's going to be 2 times x to the first power. Using this quotient rule, you notice how I wrote the quotient rule out? It kind of guides me in the right direction. So f prime of x is equal to f prime, little f prime, cosine of x times g of x, which is x squared, minus g prime, which is 2x, times sine of x, all over x squared squared. I'm going to clean that up a little bit. I'm going to take out an x right over here. On the two terms, f prime of x is equal to, factor out an x, you get x times cosine of x minus 2 sine of x all over x to the 4th. Notice one of the x's cancel. So end with x cosine of x minus 2 sine of x all over x cubed. And there it is right there. Notice something. The x's cannot cancel because this is on the inside, that's on the outside. Cosine of something is, you cannot cancel one of the x's from the denominator and numerator. Okay? Let's take example number 9. Y equals tangent of 2x squared plus 1. To take the derivative, what we're going to do is take the derivative of the tangent. You should know your sine, cosine, secant, cosecant, tangent, cotangent by now. If you don't, you can review one of my previous videos. The derivative of tangent is secant squared. The inside stays the same, 2x squared plus 1. And then times the chain, which is the derivative of this right over here. The derivative of 2x squared is going to be 4x. And then the derivative of constant is 0. I like to put this out to the front. So y prime is equal to 4 times x times secant squared of 2x squared plus 1. And there it is right there. Okay. Example number 10. We have x is equal to cosine cubed of 1 minus 3 theta. You want dx d theta. The cube is killing me because I don't know what to do with that. If you want to rewrite it, you should know how to rewrite it by now. It's going to be cosine of 1 minus 3 theta to the third. That way you can see this a lot better. And so this cube is actually on the outside. Use the power rule, bring it on down. As soon as you bring the power, use this power rule, product rule, quotient rule, chain rule, you've actually taken the derivative. So it's going to be dx over d theta. The instantaneous change of x with respect to the instantaneous change of theta. That's dx theta, that's the derivative. Bring it on down. Inside stays the same, cosine of 1 minus 3 theta squared. It's minus 1 right there. So you notice that the inside stays the same. Bring it on down, subtract 1, that's the power rule. We have to take derivative of the inside, the cosine. The derivative of the cosine is going to be sine. The inside of that stays the same, 1 minus 3 theta, times the derivative of the inside of 1 minus 3 theta now. So it's got two chain portions. The derivative of constant is 0. The derivative of minus 3 theta is going to be just minus 3. I'm going to clean that up, really nice and neat. So dx over d theta, multiply the 3 and the negative 3, negative 9. I like to use this factor first. Sine of 1 minus 3 theta times, I'm going to bring the power back into the inside right there. So I'm going to rewrite it, call it cosine squared of 1 minus 3 theta. There's some things you can do with this, but we're going to leave it at this situation, okay? So it's a little bit tricky. You have to use two chain portion. Think of a chain this way, goes on forever until you get just to itself. Let's look at y. I want to find the derivative of y prime. The derivative of y, which is y prime. Y prime. The derivative of e to some function is itself e to the sine of x plus 1 times the derivative of the inside, which is this portion right over here. The derivative of sine of x is going to be cosine of x. The derivative of constant is 0. So it's going to be times cosine of x. Clean that up really nicely. You get cosine of x times e to the sine of x plus 1 on the exponent. Okay. Next problem. Example number 13 is a little bit difficult. The g function is equal to 1 plus sine squared of 3x to the 4th power. I spent about maybe 30 seconds trying to figure out how I'm going to attack this. The sine squared, I'm going to rewrite this really neatly. I'm going to call it g of x is equal to 1 plus the quantity sine of 3x squared to the 4th power. So all I did was take that squared and put it on the outside. Okay. So as soon as we take the derivative, bring the power on down. That's the power rule. I just took the derivative. G prime of x is equal to 4. Inside stays the same. 1 plus sine squared of 3x. I'm just going to leave it like that instead of rewriting sine of 3x quantity squared to the 3rd power, because I subtracted 1 on the exponent. That's the power rule, times the derivative of the inside now. The derivative of a constant is 0, obviously. Bring the power on down. So 2 times the sine of 3x. Notice that right there, that the power came on down, subtracted 1, times the derivative of sine of 3x. The derivative of sine is cosine of 3x, times the derivative of the inside again. The derivative of 3x now is just 3. So there's 1, 2, 3 change on this one. Remember what we said earlier, you just have to get down to itself with the x's, whatever the derivative of x is. I'm going to clean that up. 3 times 4 is 12. This one goes up times 2. Let's rewrite this really neatly. G prime of x. I will always write the coefficients first. 3 times 2 times 4. That's 6 times 4 is 24. And then I'm going to write this factor first. Times cosine of 3x. Times this right there. We already took out the 2. So sine of 3x. Times this portion right there. 1 plus sine squared of 3x to the third power. Notice I could have done something with this. The cosine and the sine of 3x is the double angle, but I'm going to leave it just like that for now. I really don't know how the book did it, but let's just leave it like this. Example number 18 is the last example we're going to be doing. Y equals sine of ax plus b. I want to try to find, of course, what y prime is. Question mark. Okay, and it also tells you that the constant a is a constant and b is also a constant. So take the derivative. As soon as we take the derivative of the sine, there's no powers. You can't use the power rule. So the derivative of sine now becomes cosine. The inside stays the same, ax plus b, times the chain. What's the derivative of ax? Since a is a constant, the derivative of x is just 1. So it's going to be a. And then plus the derivative of constant is 0. We're going to take that out. So I'm going to put the a in front. Y prime is equal to a times the cosine of ax plus b. And that's your final answer. It takes a lot of practice, and if you go through the Barrons problems, it'll actually help you to become better at taking derivatives. You will definitely know how to take derivatives first part, because the second part is integration, which is antiderivative, which is extremely more difficult. So when you get to it, you'll get to it, but make sure you understand how to do differentiation, because differentiation is the key to integration. Okay, good luck on your homework. Study hard. If you have any questions, let me know. Thanks. Bye.